sound okay, Caleb? All right. Well, good afternoon, everybody. Thank you so much for coming. My name is Dr. Brian Henning. I'm a professor of philosophy and environmental studies here at Gonzaga University, and I'm the director of the new Gonzaga Center for Climate, Society, and the Environment. And this is our first live event, well, of the center, but really Gonzaga, I think we might be one of the very first sort of like just typical lecture publicly available. So thanks for being here. It's nice to see actual faces instead of Zoom boxes. The Center was for Climate, Society, and the Environment was started last April. The idea is to try and figure out how, as an institution, we can be of more service to the region, our community, our students in understanding and responding to the challenge of climate change. This event is being recorded. It's being live streamed and should be available on the Climate Center's YouTube channel for later reference if you want to be able to catch it there. And we have folks who might be streaming at home. Welcome to all of you. Before I introduce our speakers today, I just wanted to do a quick acknowledgement of the land that we are on today. In the spirit of the Jesuit practice of the composition of place, we acknowledge that Gonzaga University resides on the homelands of the Spokane tribal people. This land holds the cultural DNA and the spirit of the first people of this place, the people of the river. It is their ancestors who are here, bring forth the power of this place, the knowledge that comes from the land. This land holds the cultural DNA, and we are grateful to be on this land and ask for its support as we work to manifest our intentions during this gathering of hearts, minds, and spirits. So the purpose of this event is pretty straightforward. When we knew that the sixth assessment report from the Intergovernmental Panel on Climate Change was being released, I contacted colleagues immediately and said, you know, it would be really appropriate for this new Climate Center to host an event to try and help us to understand this new report, what it adds to what we knew before, what, if anything, we should be doing given what we now know. So that's the basic purpose, and I found two colleagues who are really well suited to this work. My colleague, Dr. Hugh Lefcort, is professor of biology at Gonzaga here. He received his BA in anthropology from University of Washington and his PhD in zoology from Oregon State University. His work focuses on ecotoxicology and the effects of pollution and parasites on invertebrate behavior. In teaching and training, his goal is to produce students that are critical thinkers. He explains that his aim is not to educate leaders or those who have a global impact or those who fight for a cause, but to train students to examine an issue from all sides and come to an independent conclusion, even if those findings stand against convention. I imagine that will be on display today, perhaps. We'll see. Our second colleague today is Dr. Betsy Bancroft, Associate Professor of Biology and Environmental Studies. She received her BS in Biology from the University of Puget Sound and her PhD in Zoology, also from Oregon State University. So we have an all OSU panel, for good or bad. Seems like they graduate pretty impressive scientists.
Same lab even, Brian.
Same lab? All right. Diversity of opinions. I thought we were getting a diverse set of opinions. I think we'll find that they are. Dr. Bancroft's joint appointment in biology and environmental studies reflects her interest in science, contextualized within real societal problems. She is passionate about promoting broad public understanding and use of science to help frame public policy and inform daily personal choices. Please join me in welcoming Dr. Hugh Lefcort and Betsy Bancroft. If you two could use the mics, that would be super. Now I'm going to bring up your presentation, or no?
Why don't we wait?
Hold on. Okay, let me know.
I don't know if this is on.
That one's on.
Okay. I'm a really loud talker, so I'm going to kind of,
But there's the
I know.
Caleb, let
Zoom.
me know if the sound is not
I'll
good.
leave it on, but I do talk loud. Is that okay, Caleb? Am I blasting you out?
You're good. Just
Okay.
you have to be in the mic to get on the record.
Okay, amazing. Okay. Well, thank you all for coming. I'm excited to be here to talk a little bit about some of the new information coming out of the report and an overall just discussion on how to understand and read these reports. As you know, because you're here, climate change is a very complex issue. There's a lot that goes into our understanding of climate. In some ways we understand it well, in other ways we don't understand it well. It also relies on understanding how science works and how science progresses, which can be frustrating. We've all seen it in the pandemic. where as our knowledge changes, the information that comes out to us changes, and it can feel dizzying at times. And if you take a look at the recent report, just the summary for policymakers is 42 pages long. The actual report is, I don't even know how many pages. It's a lot, right? So if you're interested in climate change, it can be very difficult to put it all together, right? And if you have questions, it can also be hard to dig in because there's so much science represented in this document. And so it can be a little intimidating and complex. So the way that the IPCC puts it together is to give you these sort of headline statements. And so those are sort of easier to skim and to see. But one thing that is very critical for your understanding of what we know about climate change and what we don't know about climate change, which is really equally important, right? Science is about what we know and also what we do not know. And that part that we don't know gives us uncertainty. As consumers of science, you shouldn't read that uncertainty to mean scientists don't know what they're doing, although it can feel that way. Scientists just like to be very clear about what piece they understand and what piece they don't really understand, because that tells you how seriously you should take that conclusion. And it gives you an idea of what things you might look for to change over time as our knowledge grows and builds in that area. So when you read just the summary, you'll see words in there like virtually certain, extremely likely, very likely, likely. And those words they represent a precise number, but for some reason they don't use the numbers in the report. I think it's because it feels unfriendly, right? People who are uncomfortable with numbers would rather see a word like very likely than to see 90 to 100%. But those numbers are actually very, very important. And so what I always do and encourage people to do is to sit down with the chart of what that actually means. And if math is not your favorite thing, and probabilities are not your thing, that's okay. The thing I suggest is to just convert that to a 10 and think of it in terms of people, right? So if 9 out of 10 people, something happens to them, that gives you some context. 6 out of 10 people, that gives you some context. Does that make sense? So think of it that way, if the probabilities is not your thing. All right, so those words I sort of read out to you are all through the report. So virtually certain really means virtually certain, right? That means 99 to 100%. That's pretty certain. They have extremely likely, which is 95 to 100. And again, this represents the uncertainty, right? How well do we understand this thing? How likely do we think this is? Okay? There's very likely, which is 90 to 100. And then we come on to the next category, which is perhaps the least precise category I've ever seen in any scientific document, which is called likely. And that ranges from 66 to 100. Now, I'm guessing that you would be less happy if you got 66% on an exam than if you got 100% on an exam. That's a pretty wide range. So when you read that word, you need to remember that it means something different in numbers than it might mean to you when you read it. When you read that likely, it actually means more than half, right? Like, it's probably, but not really, right? Read that as something that we don't necessarily understand very well. Does that make sense? Okay, that word always gets me reading these reports, because if you're just reading it, you're like, oh, likely, that's like, a 90% chance. It's not. It might be. But usually what that tells you is that we have a wide range of variation in the science behind whatever that sentence or phrase is, and we're still working it out. So those are those places where you expect to see in following reports sort of, resolution of that, becoming a little bit more fine in our understanding. The other thing is that they talk about their confidence in the findings. So they have this sort of scale of how much information is available, so the amount of evidence, and how much the evidence agrees. And the more evidence they have, and the more that evidence agrees with each other, the more confident they are in that information. So they tell you both of those things for all of these main points. And so you have to pay attention to those in order to really understand what they know and what they don't know. Because there are some findings that are listed that actually they only have medium confidence, right? And so if you just look at it and you're not really paying attention, you might think that we understand that piece as well as we understand other pieces. But we don't necessarily.
Good. So I think to understand the report, you have to understand how the report comes about. So first of all, it's an intergovernmental panel on climate change. It's a group of countries coming together, led by politicians who then send their scientists to put the report together. So there's nothing new that's generated from the report. So for instance, the last report, AR5, came out in 2013. The most recent one came out last month, AR6. So for AR6, what happens is, starting about 2 years ago, all the papers that were published from 2013 to 2019 are looked at. And so scientists like Dr. Bancroft and I are constantly doing work and publishing papers. People look at what we knew before 2013. They then look at all the papers that have accumulated since then, and then they try to go down this list about, have tornadoes increased? What's the chance of different events occurring? So the scientists then get together, and hundreds of scientists write this report. Then there's another 1,000 scientists like me that read the report and review it. And there's a couple of drafts where it's, they look at the comments and they produce another draft, and you look at that draft and you send in more comments. And then the report is finally written. So that's the 1,000 pages of the report. And I really encourage you, it's not in complicated language. Even the scientific part isn't in complicated language. Part of how they explain how they got it is complicated, but definitely you can download it for free. You just Google it, IPCC AR6. It's easy. So then there's the 1,000-page report in about 10 different chapters. Glaciers or effects on agriculture or different categories. So that is solid. That's what scientists do. It's basically a giant meta-analysis where you're looking at what's known. People sit around and, like Dr. Bancroft's saying, they look at, what are the odds for what we know, and then kind of what's the consensus of the people sitting in the room. Well, we can go through facts. So say you were looking at the basketball program. You would measure, how tall are our players compared to other schools? That's a fact. How fast are our players compared to other schools? That's a fact. That would give you the first part, the first numbers that Dr. Bancroft was talking about. The second number would be, okay, given that we just went over all those facts, do you think we're going to go to the Final Four? And, the room's saying, well, I'm judging this and I'm judging this, and here's our consensus about, we think it's likely, we think it's highly likely, we have medium confidence that we're going to. So there's two different ways of measuring the same thing. You're still measuring how fast the players are, but one is just an absolute value and one is consensus. So you then have this 1,000-page document, and realize that all the papers that go into it aren't using numbers like likely, meaning 66%. They aren't using numbers like main driver of this, which, does anybody could give an example of what number they think? If I said the main driver of something happening is X, what percent would you assign to that factor? Since it's topical, Mark Few. Main driver, Gonzaga success.
Just a guess,
Above
above half.
half?
50%.
Okay, above 50%. Anybody else? So if Mark Few came or went,
I think it should be a little bit higher than just the upper half. If you're talking about the main driver, like the main driver is carbon dioxide, main driver is climate change, it's got to be more than half.
okay. Anybody else? Yeah, in the report, it's more than 50%, 50% plus. So somewhere between 50.1% and 100%. That's what main driver. So we've got these words, but the papers they're based on aren't words. Most of the papers we publish, and there's plenty of arguments why this shouldn't be, but most of the papers that we publish, you're generally held to a 95% standard. There's a lot of problems with that, which we could go into at length, but that's kind of popular within the scientific community. If you get above 95% confidence, you can say something significant, statistically significant at that level, which is the same way of saying, I think this is true, although definitely with quotation marks on that. Below that, usually you just say there was a trend. So the papers are solid, but then you're compiling all these papers. But the final report is great. You read the report, it is so impressive reading it, it is so impressive watching the process. But then there's another whole part to the IPCC report, and that's the 46 pages, which used to be 5 pages. It used to be 2 pages. It used to just be a cover sheet, if you go back far enough. Now it's quite long, and that's the part for policymakers. And that's where you get, if you read the popular press, you start hearing things like the world's on fire. That's coming from the policymakers. So that's the politicians and their aides taking the report and saying, okay, now we have to actually do something with it. We need to get the world together. They're not lying about what's in it. It's accurate what they're writing. It's just the nuance is gone. The 1,000-page report, which has summaries in it, each chapter has its own summaries. Incredible nuance, saying exactly what we know, exactly what we don't know, couching words, being very careful to say something we don't know. If we don't know, we say we have low confidence, and you can, the chart is there for low confidence means, whatever percent that is. When you then read the policymaker summary, the nuance is gone. And it's a very different document. And I never saw those in the 2 drafts. Reviewers weren't shown that. So there was no, I assume somebody looked at it, but there was intense review of the scientific report, but not of the policy. And unfortunately, it's the easiest thing to read. It's in the simplest language, and it's what NBC, ABC is going to read when they're looking at it. And it's not that it's wrong. It's just
The words matter more.
the words matter
You got to
more.
pay careful attention to those words I talked about at the beginning, right? You just got to have a key looking for that, because they report them, but the statement is not as clear as to what we know and don't know,
Right.
unless you're paying attention.
So that's the problem. But, it's a problem. Climate change is a problem that is has 1 foot in science and 1 foot in policy. And, it probably has to be this way. But the two just don't play well together. As like Dr. Bancroft was talking about with, COVID and vaccine, as soon as an issue becomes politicized, we're talking about a virus here. It's as basic as it gets. But as soon as you politicize it, suddenly it becomes very hard to discuss it. It becomes very hard to solve it. So unfortunately, climate change is science-based, but then we're going to have to change society, and that involves politics, and that involves culture, and all these other things. It makes it very hard to solve those type of problems. We're not good at those problems. We're good at really simple problems like, how thick should a brick wall be? People don't get excited about it. No one's anti-brick wall. We all want to hold up roofs, and we tend to just agree. But when it comes to these other issues, our heads are loaded with all of our other petty differences. So that's what makes it such a complicated story. And why you guys really should try to engage with the document and read it yourself. It's not that hard. And then even more, read the papers. It cites all the papers that the data are based on. Go back and read them. Just pick like one subject. Say you're interested in tornadoes. Just you don't have to read that much. And it's really interesting to see how we know what we know, because science is a process of understanding the world out there.
But if you don't want to do that, because some people really don't like reading scientific papers. Hugh and I obviously like them, right? But a lot of people aren't comfortable, right? Or it's just not something they want to spend time on. The summary document that Hugh mentioned in each of the chapters for not in the technical summary, the actual report, is really quite good. And that's a good place to a good place to split the difference, right? So if you really want to know more detail, but you really don't want to pull journal articles and read them. That's a really good place to kind of focus some attention. So I would say, are you good? Should we
Yeah.
move on to? Okay, so thinking about sort of what's new in this report. The thing that really struck me is that there are a number of things that we understand much better now, and confidence has increased in this version of the report. And there are still things that we don't understand very well. And that's a beautiful thing about science, right? Because science is constantly changing, we're constantly learning. And so these reports really reflect that. And when you look over the whole history of these reports since the inception, it's fascinating to look to see how our information and our knowledge changes and grows. We know, right, we are fairly confident, very confident, I would say, that there's no way to explain our current changes in climate without including the influence of humans. And this is sort of groundbreaking to the general public because for a long time the conversation has really been, well, we don't know if it's people, right? And there's really no way to see the patterns that we see without including the influence of humans on our climate. So that's not an argument anymore. That's reasonable to have.
Yeah, and even beyond that, not only is it humans, but we understand it's mainly driven by certain greenhouse gases like
Exactly.
CO2 and methane. So those arguments get stronger in each report. But once you have a driver causing things, you can then look at all the predictions that come out of it. And so that's where it gets a little fuzzier because some of these predictions they haven't come true, and maybe they will come true tomorrow, but they're not here now. But that's where you need more of a nuanced eye. So if you look at what actually has the report reports on what's occurred, we can initially look at, so if you think about where some of this starts at, definitely at a political level. So there's a major motion picture made by Vice President Gore in 2006, the idea that CO2 is going to cause things like hurricanes. And that's definitely what the models show. So the other side of the report, not only is there two reports, there's the scientific report and there's the policymakers report, but there's two parts within the scientific report. There's what we know. We actually go to a glacier and measure how much it's melted. That's just a fact. That's how much it's melted. On the other hand, you can make a prediction on how much it's going to melt tomorrow. So that's
A projection, Hugh. It's not a prediction. It's a projection.
Projection. Yeah, projection of, oh, sorry. You can make a projection of how much it's going to melt tomorrow. So that's a different part. And the problem is modeling the entire globe is very difficult. And just because you can't model it doesn't mean it's not true. I mean, before Einstein, we couldn't have modeled how the sun was actually functioning because we didn't understand, E equals mc squared. That didn't mean the sun wasn't blazing away for 4.5 billion years. So the fact that we have problems understanding clouds makes it hard to make projections. Nonetheless, that doesn't suggest that CO2 or methane aren't the main drivers of these changes. So the weakest part of the report, in my opinion, are these projections. We're incredibly good at measuring what has occurred. Trying to put it in the future is a problem. So if you look at what we definitely have detected and what we attribute, heat waves have definitely gone up, and we know that's due, or we have a fair idea that that's due to greenhouse gases. Same with heavy precipitation. Storms have gotten more intense, and they come down hard, and they cause problems like in Houston last year. And so that's also attributed. Flooding, there isn't evidence. As much as you heard about the flooding in Germany, there isn't evidence that rivers are flooding more. At least it's not strong enough that it reaches some level of confidence. Drought, you can divide drought in a bunch of different ways, meteorological drought or hydrological drought or ecological drought, depending on how you measure it. Ecological drought seems to be occurring, but not hydrological or meteorological drought. So it's whether you're talking about the organisms that are in the soil or just the soil itself. There's different ways you can divide that up. Cyclones, which is just the technical term for hurricanes, haven't increased, and we can attribute them. This is all AR6. we can attribute that to CO2. Winter storms don't seem to have changed. Thunderstorms, tornadoes, hail, lightning, extreme winds. Fire conditions definitely have. Fire, as you can tell by outside, fire is worse, and that seems to be due to dryness, getting back to ecological droughts induced by greenhouse gases. Do we want to present models?
So do you guys want us to present, or do you want to ask questions?
Thanks.
Yeah.
One second.
My question was about how we don't see the detection of these winter storms, of these floods, but we still have like news coverage of them saying like this is like historically the lowest like temperature we've recorded, or like historical like records are like being broken and reported. So how, like, I guess why is that so different in the IPCC report, and what would you say would like make it so that it would be detected, or like how far are we from that, I guess?
Yeah, that's a really good question. So the part of the problem, right, the reason why it's hard is because the climate system is very complex. And we've had so much variability over the history of climate that we understand, right? When you look back in records, there has always been a lot of variability driven by a number of things that are still happening in our current climate system, right? So things that we consider to be more natural. They've been happening since climate existed, right? So it takes a lot of, so the way that scientists understand climate change is that it has to be a pattern. And so the place to start is looking at the pattern, the historical pattern and the current pattern, and looking to see if they are statistically different from each other is one way to do it. And so although you might have, you know, oh, this was the lowest recorded or this was the hottest recorded, that doesn't necessarily mean that that is an indicator that it's part of this larger climate pattern. It could just be an anomalous year in the historical climate pattern. That's what makes it really difficult, because we do see those big anomalies through the history of the evolution of Earth. And so the attribution piece is complicated, figuring out, is this climate change or is it not climate change? And because we can't make, you know, a million Earths and mess with them, we're limited in the tools that we can use. So we have statistical approaches and we have climate models, which are essentially lots of mathematical equations to represent the different compartments of the climate, messing with how they interact with each other and what their starting values are and what the inputs are, and looking to see, okay, we can run it in all these different ways. And when we do it in all these different ways, how often do we see that anomaly?
Also, it gets to the fact that you've got predictions, you have models with projections. So from a rise of CO2, you can put it in your model, you should get more hurricanes. So you can have footage, a CNN footage of a hurricane, and say this is consistent with with projections of the IPCC. On the other hand, it's just as true that hurricanes haven't gone up. So you can say the same thing, hurricanes haven't gone up, but it is, if you see a hurricane in front of you, that is consistent with the model. And that's why I'm saying models are great for getting you to go outside and test something. Models are not data. Models are the start of collecting data. Now, some things you can't do astronomy, you can't go to another galaxy. That may be how that's as close as you're gonna get. But it isn't the last piece. So you can often have something, and that news report is correct. It's just that if you look at the data, it doesn't seem that hurricanes, at least up till now, have increased. They may be a little slower, and so they sit over your city longer, but globally they haven't increased.
One quick question for you here with regards to heavy precipitation. So you have yes for detection and attribution. Isn't there a direct correlation between heavy precipitation and things like flooding, thunderstorms, tornadoes, hail, etc.? Could you just clarify the distinction there?
Sure. I mean, heavy precipitation should lead to more flooding. We know there is more heavy precipitation, but we also know there's not more flooding. So, you know, does the water get trapped somewhere else? Are cities good at diverting it? Spokane just spent millions and millions of dollars building over 1 million gallon tanks strategically located. So you could have heavy precipitation over Spokane and no increase in flooding simply because we spent the money to take care of that water. So that both can be true. Even though you're totally right, logically you'd expect more based on the prior fact.
Thank you. And then my second question would be in relation to 100-year design storms. So historically, we've built infrastructure systems based on 100-year design storms. How much is that changing? And then how much is our school and how we're being educated changing along with these changes that we're seeing?
Yeah, that's another really good question. So this report actually has some interesting. Do you have those data? Those little grids? No, not for Spokane. In this report, they have a figure. I think it's in here. Yeah. Do you have this one in there, Hugh? No. All right. Well, in the report, they actually have some projected changes. So again, these are the models that Hugh's talking about. And I have a little bit more confidence in models than Hugh does. Yeah, it's a conversation. Hugh and I don't agree on a lot of things, and it's awesome. We love to chat about stuff. So these climate models, right, are not real. It's not truth, right? But science never gets at truth. And the way these models work is that it essentially gives you pretend worlds that you can mess with, right? And so we never really recreate the climate system of the Earth because we can't do that using mathematical equations. But you can get in a ballpark, right? And so yes, it's true that it doesn't give you the final answer. It gives you an idea of what you might see and the range of things that you might see, which is useful for planning. So to your question, there's a projected change as an extreme figure that gives 10-year events, 50-year events, and how likely those things are to occur more frequently under the different scenarios that they use in terms of emissions. So just to give you an idea, you know, these 50-year events, for example, historically over 50 years would occur once, right? That's why they're called 50-year events. And then under the higher emissions scenarios, right, we'd expect to see those historically 50-year events every, you know, it would occur like 39 times in 50 years, right, under the really bad situations and the bad scenarios, and, you know, maybe 4 times in the lower emission scenarios. So we're expecting these events to come more frequently. But how much more frequently they're going to come is very hard to know. And so there's a wide range around those estimates, right? So it could be once every 50 years. It could be much larger than the 39. So there's a lot of uncertainty inherent in those. And so for planning, thinking about planning, right, we just have to be more nimble as a society and use that uncertainty when we do infrastructure. Recognize that things are changing and that we need to plan for them and that we don't necessarily understand the intervals of these storms anymore, and we need to overbuild in order to protect society. And in terms of education, I don't know how much we're teaching people about that.
No, the planning is a key point. So, you know, to actually reduce CO2 rise is a much larger problem, and you're dealing with a lot of poorer countries that are becoming increasingly affluent and living more like us and having a much heavier footprint. But the one thing you can do is you can definitely harden your cities. So Hurricane Katrina is the perfect example. Hurricane Katrina back in 2005? That was a Category 3 hurricane, and it hit a city. Now, granted, the city was built below sea level at the end of the Mississippi, which drains 2/3 of the country, next to a giant lake and next to the ocean. So not the best place to build it. Nonetheless, the city flooded with a Hurricane 3, Category 3. Last month, when we had another storm, it was a Category 4, and it was actually just 5 miles slower than a Category 5. And because of all the infrastructure we put in after Hurricane Katrina, the U.S. Army Corps of Engineers, the city survived and it didn't flood. So obviously it would be much better to prevent a problem rather than work on cleaning it up. So if coffee's spilling off of here, we wouldn't just constantly clean the floor and wait for more to fall. But unfortunately, given our species, that seems to be all we seem to be capable of. So we can actually harden all these sites, like building the giant tanks that Spokane has built, or what we've done with New Orleans. So that's doable. I think it's an inefficient way to go about it, but if it's the best we have, we can definitely do that today. But that requires planning and trying to make predictions about, do you prepare for a 100-year storm or do you prepare for a 1,000-year storm? Most people would say, well, I don't have the money for a 1,000-year storm, but because realize a 100-year storm doesn't come every 100 years. If you have 100 locations that you're watching the news, every year, one of them will have a 100-year storm. And that's part of the problem, that we are watching the news for the entire globe. And so every time something happens, we go, oh my God, something just happened. But, the people who lived here, like Dr. Hennings was saying, hundreds of years ago, the indigenous people here, they only knew about what had happened right here. So events were rare. For you and I, events are no longer rare. We hear about every single event that occurs globally. So you're taking it in every day going, my God, it just happened here and it just happened there. So 100-year storms happen. There's a 1 in 100 chance it's going to happen to you each year. You run it out 100 years and it'll probably happen. But it doesn't mean those are really rare events. But those are becoming more common. So we can definitely harden ourselves to prevent those or to lessen the damage.
So one thing that is not necessarily new in this report, but was sort of strengthened by this report, is that we are essentially committed to a good deal of warming. So we are expecting to hit that 1.5 degree C global increase, just the historic emissions that we've had. So scientists for several years have sort of understood this, and the conversation has turned a lot in scientific circles from, okay, climate change is happening, to, okay, how do we create resilient ecosystems? How do we help these systems prepare for the change that we know is going to come? And what are the best ways to do that? And one of the things that Dr. Lefcort and I both agree on is that land conservation is an excellent way to go about doing that. One of the reasons why New Orleans needs such heavy infrastructure is because their coastline is heavily impacted. And if their coastline was intact and you had mangrove forests like historically you would have, we wouldn't have to invest so many dollars. And so all of the infrastructure that Hugh just talked about is very expensive. It is incredibly expensive. And New Orleans did much better than other smaller cities that weren't protected from IRA. So one of the things to think about is that if you're worried about climate change and you care about sort of environmental issues, one really important way that we can solve a lot of problems is through land conservation and land protection. And it's a good way to target energies, and will solve a number of issues.
Yeah, just to emphasize that, I mean, not only does habitat protection solve all these other issues, but it also politically is the easiest way to do it. Nobody builds a shopping center because they want to see a new store. They build a shopping center to make money. People sell land because they want money, which means if you offer them more money, they go away. They don't lobby, they don't go to Congress, they don't sue you, they don't start a political movement. People are happy if you give them more money than they thought they could get by, taking a forest down and, plowing it. And so it's very doable. It is expensive to build like million-gallon tanks, certain parts, but setting aside land, you don't get political opposition. Then you get all these other pluses. So not only do you get all these services like clean water because you have areas that filter water, but you get recreation. Think about the advantage to Gonzaga to having the river be nice. We can attract better students, more students. We can charge them more because it's a better product. There's a bunch of pluses. And the main thing is, so if you think about, you have a pool of money to deal with these environmental issues, where do you get the most for your money? And saving land is one of the best ways. Also, if you think about past extinction events, the way we came out of those past extinction events, if you're going to lose 50% of a species, if you start with a lot more of the species, because you have a lot more land, then when you come out the other end, you just have more. So, you know, we live in a part of the country where land is still, you just go west of here, it's still $2,000 an acre. You could set up huge tracts of land for very little money. We could use it for labs, we could use it for research, we could use it, open it to public recreation. You know, it's just win-win. No one is going to oppose you. So there are definitely things we can do with our money, and there's things that are much, much harder to do. And those generally involve politics.
In regards to, writing a report like this, you mentioned there is X amount of editors and X amount of writers. Does that fluctuate, and how do you get selected to be involved with a report like this? And also not only the folks that participate in a report like this, but do the subjects change from report to report, and how is that selected?
The subjects change slightly. People start worrying about different things as it's evidenced. Like certain greenhouse gases, we didn't know were greenhouse gases before, and so the subjects do change a little. But basically, so governments themselves appoint the scientists, and then the reviewers, I think I filled something out, and then they just look at who applies, and you don't get paid, it's just volunteer. But it's super interesting to see something early. The toughest thing is that you have to keep it secret. So you've got this like 7-year secret, and you can't say anything. And you don't even know if your secret's going to be the final secret. So that's the other incentive why you don't want to say anything. Things that I thought were in the report weren't. And I don't know why. They were before.
Dr. Lefcort, did going through that process make you more confident of the result or less, having been a peer reviewer?
Definitely more confident. I was so impressed, not by the models, and not by the policy position, but the 1,000-page report, how careful things were figured out, and how detailed and just how many studies people looked at. It was really impressive how much work some people did. I mean, and it's easy to review something, but to compile it, that's the work. And just I mean, the word is exhaustive. It was an exhaustive compilation of data. And it's so hard because in science, I mean, Dr. Bancroft actually does meta-analysis where she's looking at reports that one say one thing and one says another, and you've got to like piece it together. It's really hard to get that 1,000-foot view of something when there is background variation and there's studies showing this and studies showing that, and you got to figure out what are the good studies, what are the weaker studies. So no, definitely more and more impressed by the report, but much less impressed by the summary. Because especially when you work on something, to see them then take that and change it slightly, I didn't see the need for the summary to begin with. And I definitely don't like those numbers. Both times I complained about, likely being 66%. That's not how scientists talk. I could see that in the summary, but I didn't see why we should put that in the scientific part, because we don't talk like that to each other. But, I'm just one person.
My understanding is that given that this is a document of the Intergovernmental Panel, and it's trying to create a document that is meant to guide policy making intentionally, that it's not just a meta-analysis of all the research done in the previous period, that the summary for policymakers is that layer of inviting politicians to then say, do we all agree with this? Which is a strange thing to do with science. Like the scientists are saying, this is what we think is true, this is how true we think it is. But I can see the utility if you wanted this to guide policymakers, to give the world's leaders a chance to then say, do you agree with this too? What typically people who are advocating for action would point out is that if it's in the summary for policymakers, it's usually more conservative, not less, because usually the consensus-making process usually waters statements down. it waters them down and makes them less accurate scientifically, potentially, but it also waters them down in the sense of it's easier to get agreement with Kuwait and Qatar, and the UK if you reduce the statements somewhat. So if it's in the summary for policymakers, it's probably that bad or worse, not usually better. Would you agree with that?
So I think it goes both ways. It's definitely true that some things do get watered down in the policy, and generally they're like these hot button issues like Kuwait wants to pump more oil. But they'll go up on some things and they'll go down on other things. And to me, it's just, you've got this perfect, as a scientist, you've got this perfect document. Why would you screw with it at all? Why would you add politics to it? And I understand, we live in a political world, but it's my point that these two worlds they're two majesties. They don't mix well. And that causes issues.
Yeah, I agree with you, Brian, that this needs to exist in order to tell people who don't want to get into the science what the science is saying. I think maybe the root of a lot of the uncomfortable feelings that Hugh's expressing and that I also feel at times looking at these documents is that people in general, and politicians in particular, don't operate under uncertainty. Uncertainty is not something we're good at politically. And incorporating that uncertainty into conversations is not something that happens. And this is true at all levels, in terms of just any issue that science deals with. Scientists are really into their uncertainty, and we really live and swim in that idea. The general public does not. And so to scientists, all that stuff really matters. And it's imprecise if it's not included and it's not very clear. And so to Hugh and I, this is a very imprecise document. And so I think that's the root of that conflict and that concern. I think, though, that this is necessary because politicians aren't going to deal with that uncertainty anyway, right? Like it's there, and that's just not how we operate. The thing that worries me is when you see one of the figures in here, and the uncertainty is not emphasized in the way that it should be, right? So I'm looking at this example document. And it's this beautiful map of changes that we've seen and things we expect. And then there's little tiny dots in each of these hexagons telling you the confidence in that result. And if you don't pay attention to those, it all looks like it's equally well known. But it's really not. And so that's the piece I think that needs to be better communicated in these documents, is this document should focus on what we do know, and should not include these pieces that are not as well understood. And I think that then Hugh might feel better about them because they all read as equally known and equally important in a casual skim, or even just a real in-depth read by someone who doesn't understand sort of how science works. And so to me, I think that would solve a lot of the issues if this summary document was very limited. You hear people complain, though, that the IPCC is too conservative, and that they have too high of a bar. And so there's discussion in the scientific community as to how this should be managed and how this information should be communicated. And it's complicated. I don't have the answer.
Hi. I was wondering if you could elaborate a little more on land protection, because if it's, a great solution, I'm kind of just curious why so many development companies and political figures have been trying to destroy natural habitat and take away from conserved and public lands, and what the reason for that is.
So I think Hugh misspoke a little bit when he said no one protests land preservation, because I'm from Utah, and there's lots of protests about land preservation in Utah. So I think it's more complicated than we sort of casually spoke of it. But I think it gets to exactly what Hugh mentioned earlier, which is money. That people who own land want to be paid the value of that land. So I think that the conflict there is that land can be put to so many uses, and land has different values for different people. And so if you are mining for oil or gas, that land is more valuable to have that resource extracted than it is to sit and have people hike on it. And so that's where that conflict really comes into play.
Also, you can think globally but act locally. I mean, we're sitting in a building that's 5 times bigger than the old COG. That was a little dowdy, but it worked fine. Now, this building is built to high green standards, but reduce, reuse, recycle, we had a building. And tearing it down and building something 5 times bigger is not reduce, reuse, or recycle. But we had a problem that we have more and more affluent students each year with bigger and bigger student loan checks in their pockets, and we had to build this building because that's what you guys expect. And so you could argue it's hypocritical. I don't think it's hypocritical. I think Gonzaga has a great mission, and we want to teach you that mission and teach you certain values. But the only way to get you here is by building this palace. And so, development, we have another building going on this campus, 2 buildings. So, if you think about it, we don't lack in space. If you walk into College Hall after 4 o'clock, it's empty. So it's basically used from 9 to 4. We don't even use it during lunch. We just take a whole hour. We just say, middle of the day, we're not going to use it. So we could definitely run these buildings harder. We're heating them anyhow. We're cooling them anyhow. We choose not to because it's just more convenient not to have a class at 8 o'clock at night. And I understand that. But we could have a smaller footprint. We could charge less. We could have almost a community college at night. We could do a lot of things that we don't do simply because of inertia. So you can point to big business, but there's plenty of pogo type issues right here that we demand certain things. Things like coming back after Thanksgiving. We could easily end the semester at Thanksgiving. You guys only come back because we make you come back. So you fly out and then you fly back for another week. We could start a week into August and end at Thanksgiving. And you would come back January 1st. And you'd have 6 weeks to get a job or do whatever at home. But that's inconvenient. This is how we do it, and we like doing it this way. So, so much of these land use things are attitudes about consumption where you could just work a little harder. You could have a class a little bit later in the day, and we just wouldn't have to build new buildings, and we wouldn't have to take more land.
I have one more wonky question as we wrap up. Have they changed the use of the representative concentration pathways in this report, or are they using the same models? And like in a 2-minute version of how they're transitioning the RCP moving forward?
So I don't actually know the details of what's changed, but so the way that they do these projections that Hugh really quibbles with, right? And they are definitely projections, not predictions. The word matters, right? Because scientists can't predict the future, right? So it's taking what we know now and overlaying it into the future. So it's a projection, very clearly. But in order to do that, we have to make some assumptions about what our emissions will look like, different nations that are currently developing, what their emissions will look like. So there's a number of assumptions that go into these models. Historically, the last 2 reports, I think, they used these RCPs, these resource concentration pathways, which I don't know who came up with that, but that is word salad and means nothing. But they were basically these emission scenarios with some human behavior worked into them. So they've changed those in this document, and they're now called SSPs, which stands for, I wrote it down. They're shared socioeconomic pathways, right? And so that's more descriptive than a resource concentration pathway, certainly. And it's basically, again, these emissions scenarios and associated human behaviors and how we as a global community might reduce our sort of carbon emissions for the most part, but also methane and other greenhouse gases. And the thing that I think is interesting in this is that the whole time I've been working on climate change, that top level scenario, like the worst case one, was really the path that we were on. And we've made enough strides culturally in the global community that we are no longer on that worst case scenario. So the most dramatic SSP that's in here now is worse than we actually expect it to be, which is really amazing to me that we are actually making some headway there. So when you look at the report, keep in mind that worst case scenario is no longer the path that we're on. We could still get on that path, certainly. We expect a bump in emissions. So the pandemic really cut back our emissions. We're expecting a bump as the economies of different countries are coming back online. But overall, we think that the changes we've managed to make so far have reduced us in our overall projected emissions, which is really great. But I'm not sure sort of what's different about them other than they've changed the name and they're thinking about them a little bit differently. Sydney.
Are the changes really just due to the pandemic, or are there other things going on that contributed?
No, the emissions were down before the pandemic started. So it's really, some of the agreements from the Paris Accord in 2015, just progress by various countries in Europe. Some of the progress in this country have reduced the emissions.
Yeah, so I mean, our levels peaked in 2007. They're down 28% since then in this country. But that is largely almost all but a couple of percent due to fracking. So fracking is, once natural gas was fracked, it's cheaper than coal. And natural gas produces a lot of greenhouse gases, but it produces less than coal. So again, that was a technological solution rather than a cultural solution.
So we're just about out of time. Let's start off first by thanking Dr. Lefcort and Dr. Bancroft. One of the things I'm learning from this is that it would be really useful and interesting, I think, to invite someone to come to campus and talk about climate modeling. And maybe Dr. Abatsoglu from UC Merced or someone else from the CERC team that's using climate modeling and talk about the difference between physical science and climate modeling and maybe have a conversation about that. That sounds like that would be useful because there's a lot of reliance on projections in this report, more than in the past, more explicitly. I guess I would put it that way. So that would be interesting. So stay tuned and look for that. These are some of the other events that we have coming up. You can go to gonzaga.edu/climate center events and register. I hope to see you at those. And thanks again for coming to our event today. Grab a piece of fruit on your way out.